Translations. Okay, we are going through translations. So, what was the, I guess, nickname for translations?
Transformation.
Not a they're all transformations. It's a what? It's a slide.
Oh,
It is a slide. Okay, so a translation is a slide. So when I slide a figure. So a translation is a slide. So today we're going to focus on translations. Tomorrow we're going to focus on reflections. And then Wednesday we're going to focus on rotations. We'll do all three of those all again on Thursday. And then you will take a test on Friday. Okay? So
every single
what
would be like
is a translation? A translation is a transformation that
PDF.
maps lines to lines.
Wait, is this the day one?
Yes, it is.
Oh.
Raise to raise. And angles to angles. By sliding a figure. Transformation that maps lines to lines, raise to raise, angles to angles by sliding a figure.
Can you please wait for like a second?
I sure can. Okay, notations. We write this as translation of L or T of L. It can also be written, or this is what we call function notation, XY with an arrow, and then we would have X plus or minus a number, and then Y plus or minus a number. Okay, that plus or minus could be switched out.
What is between the X and M?
A plus and a minus sign, both of it, like, because it can be one or the other. All right, this is how it works. It moves a figure. Left or right, and up or down, about a plane. Can I move up to there?
Yeah.
All right. So it says A is 3, 5, and B is 0, 5. Translate left 3 units and 6 units down. So what I'm going to do is from A, I'm going to draw the lines to show you how I'm moving. Okay? And then I'm going to erase the lines once I get to my point. So from A, I'm going to move left 1, 2, 3, and then I'm going to move down 6. 1, 2, 3, 4, 5, 6. And that's where I'm going to put my new point. And I'm going to mark that as A prime. I'm going to go ahead and delete my lines because I don't want them there to confuse me, and I only want the point that I translated. Okay? So make sure if you're putting those points that you do go back and erase them to where it's not confusing as to what your actual point is.
You mean the lines from the point?
Yeah, the lines. I'm sorry, the lines. That's right. Okay? So B, once again, I'm going to go left. 1, 2, 3, and then down. 1, 2, 3, 4, 5, 6.
I mean,
I'm
I have a
going
question.
to put this point, label it B prime, and then I'm going to go back to delete my lines. Then I'm going to draw a line to connect my 2 points. Yes, Suzanne?
Okay, can you like measure the?
You can.
MD?
You can, but when you have a figure that has multiple points on it,
Okay.
can you do that? Or when it's going on a diagonal, can you do that?
Yeah, if you're smart enough.
But are you?
The easiest foolproof way is just to go ahead and count your points. Okay? All right. So what is A prime? What are the coordinates of A prime? What-
0, 1, 0.
0, not 0,
0, negative 1.
negative 1. Okay, what is B prime?
Negative 3, negative 1.
Negative 3, negative 1. What do the pre-image and the image have in common?
I mean, they didn't change size.
They're the same size, right? Are they the same shape?
Yes.
Yes. Normally they would be the same what? Same angles, but do we have angles on these lines? No. Okay, let's look at number 2. C is negative 5, 6, D is negative 1, 2. It says translate right 3 units and down 2 units. Okay, so here, I'm going to start at C and I'm going to go right 3, 1, 2, 3, and then down 1, 2. I'm going to put that point and I'm going to make sure I label it C prime. Okay? I'm going to do the same thing for D. I'm going to go right 1, 2, 3 and down 1, 2. Put a point, label it D prime. Then I'm going to go ahead and draw my line. Okay, what are the coordinates of the image? What is C prime?
Negative 2,
Negative 2,
positive 4,
positive 4. What is D prime?
0, 2.
Not 0, 2, but 2, 0. Remember, if I move left to right, that comes first. Okay? What is the relationship between the pre-image and the image? They are, the relationship is going to be they are congruent. Explain why. Same what? Same shape and size.
Isn't same congruent like exactly the same? Like the same shape, same size thing, if you just put the they're congruent?
let's look at 3. 3 says E is 3, negative 3, and F is 5, 0. Then it has x, y with an arrow, x, y plus 2. This right here is what we call function notation. Okay? It is a rule of transformations, and in this case, the rule of translation. So what does that tell me to do? X, y plus 2. Well, what this is telling me is that, what? Add 2 to the y. Yes, and what is happening to my x? Stays the same. So this x is going to stay the same. Okay? This y, I am going to add 2 to it. Or it tells me to move
Right to.
not right 2, because it's y, up 2. Okay? Up 2. Yes? All right. So from here, E, if I just move up 2, I'm going to zoom back out if y'all didn't get that. Okay? Here, that's E prime. All I'm going to do is move up to here. That's going to be F prime. And that's the only move that I needed to do for this figure. So all I had to do was move up 2. Okay? What are the coordinates of the image? So my x are E
3,
prime. The x is going to remain the same.
3, negative 1.
And the y, I'm going to add 2 to it. So 3, negative 1. All right, what about F prime? My x of 5 will stay the same. And my 0 will go to
5, 2.
2. 5, 2. Okay? What do the pre-image and the image have in common? Same shape, size, congruent. They're also parallel lines. Do you see that? They will never run into each other. They're parallel lines. Okay? Any questions on this? All right, let's look at number 4. Use the graph to complete the question. Graph triangle XYZ with vertices x, negative 6, negative 6, y, negative 2, negative 1, and z, negative 2, negative 6. I want you to go ahead and try this one by yourself. So the first thing you have to do is graph the triangle. So you're going to graph this triangle. I would use 2 different colors. I would use one color for triangle XYZ, and then when you go to do your translation, I would use a different color. But preserves the size and the shape of the figure. That is going to be a rigid transformation. A rigid transformation. A type of function that changes the position of a figure but preserves the size and the shape of a figure is a rigid transformation.
Why wouldn't that just be a translation?
Because it's also a rotation and a reflection. Because it does change the size, it does preserve the size and the shape. The original figure before a transformation.
Pre-image.
Pre-image. Figure after a transformation.
Image.
A type of transformation that slides a figure across the coordinate plane.
Translation.
That's a translation. Okay, that's a translation. All right, So it says triangle ABC is the pre-image and triangle A prime, B prime, C prime is the image. Describe the motion of translation that took place. So I am going from A to A prime. How am I getting there?
Running it, 1, 2.
You're moving
One,
1,
four,
2, 3, 4, 5 to the what? Right?
Right.
And then you're moving up. 1, 2, 3, 4. So you are moving right 5 units and up 4 units. So describe the translation using function notation. The rule is going to be xy translates to x plus
4, no, 5,
5, y plus
4.
4. Okay? Complete each sentence below. Angle B is going to be equal to angle B prime. Triangle ABC is going to be equal or congruent to triangle A prime, B prime, C prime. The length of AB, how long is AB? 1, 2, 3. Is going to be 3 units. This is equal to the length of A prime, B prime, which is also 3 units. The area of triangle ABC is equal to the area of A prime, B prime, C prime. Okay? So these triangles are also congruent. Hey. All right. Let's look at the next page. The mapping notation rule tells you how to translate the figure on a coordinate plane. We first move horizontally. If a number is added to x, you move the point to the right. If a number is subtracted from x, you move the point to the left. But vertically, if a number is added to y, you move the point up. If it is subtracted from y, you move the point down. So this is the exact same thing we just went through. Okay? Let's look at example 2. Apply the translation of xy translates to x minus 2, y plus 4 to rectangle ABCD. All right. X minus 2, what does that tell me to do?
Go left 2 times and go
2
4 up.
left. And what does y plus 4 tell me to do?
Move
Up 4 times.
up 4
Up
times.
4.
Up 8.
Okay, up 4. All right, let's go ahead and do this to each point. So let's look at A. I am going 2 left and up 1, 2, 3, and 4. So I'm going to be here. I'm going to put that point as A prime. What is that point? That's going to be 0 and 9. Okay, now let's do the same for B. I'm going to move 2 left and up 9. I'm sorry, not up 9, up 4. Up 4, sorry. So B prime is going to be 4 and 9. Okay, going to C next. C prime will be here, which is 4 and 7. And then I'm going to have D prime, which is here, which is going to be 0 and 7. So I have my rectangle. What do you notice about the size and the shape of the pre-image and the image? They are the same. What is the relationship between the area of ABCD and A prime, B prime, C prime, D prime?
Congruent.
They're equal or congruent. What is the relationship between the length of side A and the length of side A prime, B prime.
Congruent.
Equal or congruent. What type of angle is angle BCD?
Right.
A right, a 90-degree right angle. So what angle in the image is congruent to angle BCD? That's going to be angle B prime, C prime, D prime. Okay? B prime, C prime, D prime. It's the exact same angle that was given before. They're all congruent actually, right? Because they're all 90 degrees. But the one that actually fits perfectly is going to be B prime, C prime, D prime.